Morning folks, Mr. Vanaut here again. I'm just going to walk you through how to calculate the empirical and molecular formula for a compound if you start with its percentage composition. First of all, let's look at what empirical and molecular formula actually are. So I've drawn here a few different types of formula and I thought we'd talk them through. First of all, here on the top left side I've drawn a structural formula. As you can see, this shows me the structure. It shows me there are 4 carbon atoms, and each of those carbon atoms has 4 bonds, and they're either bonded to other carbon atoms or to hydrogen atoms. So the structural formula tells me about the structure. It's got the highest level of detail. You can see over here, top right corner, this is a molecular formula, and all that tells me is the type and number of atoms. It tells me that I've got 4 carbon atoms and 10 hydrogen atoms. Both of these two formulae are for the same compound. They're both for butane. It looks like this if we want to see detail, but if I want a simplified form of that, without as much detail, I can write the molecular formula. It doesn't tell me how the atoms are connected, but it does tell me the type and number of atoms. If I want one less layer of detail, I can have the empirical formula. The empirical formula tells me the simplest whole number ratio of atoms present. So the empirical formula for this same compound, for C4H10, is C2H5. It tells me that for every 2 carbon atoms, there are 5 hydrogen atoms. So I can see that up here in my structural formula, if I look at just half of the molecule. For every 2 carbon atoms, there are 5 hydrogen atoms. So the empirical formula gives me the least amount of detail of the 3. It just tells me the ratio of atoms to each other. It doesn't tell me the actual type, and it doesn't tell me the actual number of atoms. It does tell me the types, and it certainly doesn't tell me the structure. So least detail, more detail, most detail. From a percentage composition, where we know the percentage mass of different types of elements, we can calculate the empirical formula. So we can go from percentage composition to empirical, and from there, if we know the molar mass of our molecule, we can go to molecular. So where we're going to go today is we're going to start from percentage composition, we're then going to calculate empirical, we're then going to go to molecular. So let's have a look at an example. So the particular example we're going to look at is going to be starting with a percentage composition of 5.9% hydrogen and 94.1% oxygen. And again, I've written the steps that we're going to go through on the side here so that you can follow along. So the first step is to assume that we are working with a 100 gram sample. If we are working with a 100 gram sample, that simply means we can take these percentages, because they're percentage by mass, and we can turn them into a mass. If I have 100 grams and 5.9% of my 100 grams is hydrogen, then 5.9 grams is hydrogen. If I have a 100 gram sample and 94.1% of it is oxygen, then I have 94.1 grams of oxygen. So that's the first step. Assume you have 100 grams and convert your percentages into masses. Step number 2 is to turn those masses into a number of moles. So I do that by dividing the mass by the molar mass. So we'll look at hydrogen here first. So if I have the mass of hydrogen being 5.9 grams, its molar mass from the periodic table is 1, or 1.0. 5.9 divided by 1 gives me 5.9 mole. Do the same thing now for oxygen. The mass I had was 94.1 grams. The molar mass of oxygen is 16. Mass divided by molar mass gives me 5.88 mole. So I've calculated the number of moles for my second step, and I've got 5.9 of hydrogen, 5.88 of oxygen. Step 3 is to divide by the smallest. So the smallest out of these two, 5.9 versus 5.88, the smallest is 5.88, just. So I divide both number of moles by the smallest, which is 5.88. So 5.9 divided by 5.88 gives me 1.003. And 5.88 divided by itself gives me 1. That's the third step. Divide each of the elements by the smallest number of moles and see what you come out with. The fourth step is to round. Now here 1.003 is incredibly close to 1, and 1 is 1. So I'm going to round both of these to be exactly 1, because when I express my empirical formula, I don't want to have h 1.003 to 01, I want to have them as whole numbers. Now a little disclaimer here, if this was 1.5, you wouldn't really want to round 1.5 up or down. What you would do there is double them both, so it becomes then 3 and 2. We'll deal with an example like that in another video. And then once you've rounded, express it as a formula. So what I've got here, for every 1H, I have 1O. So I'm going to write the formula as HO. That is the empirical formula. That tells me that for every 1 hydrogen, there is also 1 oxygen. So that's how to get from percentage composition to empirical formula. And now we're going to get from empirical formula to molecular formula. So let's have a look at a continued example here. So we've just worked out that our empirical formula is HO. So I'll write that up the top there. And now I've been given some further detail. The actual compound that I had the percentage composition of at the start has a molar mass of 34 grams per mole. Now I want to know, what is its actual molecular formula? Well, I know the empirical formula is HO, so for every 1 hydrogen there's 1 oxygen. That's useful to know. And now I need to work out, what is its actual formula? Is it H1O1? Is it H2O2? Is it H3O3? H4O4? What is the actual molecular formula? The ratio is not enough detail. So again, there's a number of steps I can go through here. And what you do is you need to figure out, what number do I multiply my empirical formula by to get my actual molecular formula. To work out that number, you take the molar mass of the actual compound. In this case, that's 34 grams per mole. I've been told my actual compound has a molar mass of 34. And we divide that by the molar mass of the empirical. So if I look back here at my empirical, I have 1H and 1O in the empirical formula. H is 1 and O is 16 from the periodic table, so they combine to give 17. So if I divide the molar mass of my actual by the molar mass of my empirical, I'm going to divide 34 by 17. And that comes out with a ratio of 2. So what I now need to do is multiply my empirical formula by that number that I've just calculated. So there's my empirical formula, HO, and I need to multiply each of the atoms in there by this number that I've calculated, which in this case is 2. So H becomes H2, and O becomes O2, and that is the molecular formula. So in this case, we started off with a percentage composition of 5.9% hydrogen and 94.1% oxygen. That's a percentage by mass. We turned that into an empirical formula of HO, where we learned that for every 1 hydrogen, there is in fact 1 oxygen. And then we went to a further level of detail, where we worked out that the exact molecule that we were investigating here, the exact molecule that we were given the percentage composition of, has an actual molecular formula of H2O2. So those are the steps going from percent composition to empirical to molecular. Hope you found this helpful. Look forward to future videos where we work through some more examples. Cheers.